Here is the next video. In this video, I'm going to talk about clipper circuit where Zener Diode is present. So here, this is a Zener Diode. So we know that Zener Diode is going to act like a ordinary diode in forward biased condition, and in reverse biased condition, it will act like a voltage regulator. So whatever that voltage, so here we have VGT equals 6.8 volts. At 6.8 volts, so VGT is 6.8 volts. That means cathode to anode voltage, as long as if you have the voltage at 6.8 volts, then it will act like a closed circuit, or it will maintain that 6.8 volts at the output. So it will maintain that 6.8 volts at the output. So first condition, so here we have a diode and Zener diode. So the first case, I'm taking the Zener diode is acting like a open circuit. As long as this is open, no current is passing through this, I equal to 0. So your V naught equal to V input. So when the Zener diode is going to act like open, when the Zener diode is going to act like open, when this voltage Vx is the voltage here, or between this point and this point, that this is grounded, so that must be 0. So between minus 0.7 volts to 6.8 volts. So if you take this sinusoidal input, which is varying plus 10 volts to minus 10 volts. So if you look at here, for the positive half cycle, up to 6.8 volts, so 6.8 is somewhere there, it's going to act like open. And again, when it reaches to negative 0.7, it's going to open. So during this period, it's going to act like an open switch. Okay, that's what I wrote. So based on this, V naught minus Vx equal to 0.7. So I'm going to substitute Vx equal to V naught minus 0.7, end up with between 0 and 7.5. My output is equal to this. So as long as my input is between 0 and 7.5 volts, my V naught equal to Vn. That is the case. Now, when this is going to be closed, so when this is closed, you will see my output equal to 7.5 volts, because plus 0.7 there and plus 6.8 there. So we'll end up with 7.5 volts. So here there is some current passing through the circuit. Current is going to go through downward. So Vn minus V naught over 2K must be greater than 0. So Vn minus V naught must be greater than 0. So based on this condition, so if Vn is greater than 7.5 volts, then my V out equal to 7.5 volts. Now third condition. Actually, we will have fourth condition too, but I'm going to go with only 3 conditions because fourth condition is not going to make any difference. So here, I'm assuming this is acting like a open switch. I mean, the diode is acting like a open switch. So this is the diode. I'm taking this part as open switch. When this is going to open, as long as Vn is less than 0.7, as long as Vn is less than 0.7, it's going to open switch, right? So Vn is less than 0.7. If that is the case, our V naught equal to Vn. So based on all these 3 conditions, V naught equal to Vn. So this is one condition. So between 0 and 7.5, V naught equal to Vn. And above 7.5, it is going to be 7.5. Below 0.7, it's going to be Vn. So if I draw the waveforms, here we're going to have a sinusoidal input. So this is my sinusoidal input, varying from plus 10 volts to minus 10 volt. That's omega t. This is Vn. Now my V out is going to be, so when you look at here, V out is going to follow V input until 7.5. So 7.5 is somewhere there. So this is 7.5. Okay, and draw this dotted line so we know exactly where to draw your output waveform. So up to 7.5, it's going to follow input. At 7.5, it's going to be clipped. And negative half cycle, there is no difference. Same as the input waveform. And for positive half cycle, it's going to clipped at 7.5 volts. So here 7.5 volt, here negative 10 volt. So it is varying from positive 7.5 volts to negative 10 volts. Okay, this is the clipper circuit with the Zener diode. So I'm going to draw the transfer characteristics. So when I draw the transfer characteristics, here is my input. Input is varying from positive 10 to minus 10. Here is my input voltage. Now if you look at my V output, y-axis indicates the V output. So look at the V output. My V output is following V input up to 7.5 volts. So up to 7.5, my V output and V input is same. So let me take this as 7.5. It's not up to the scale, but you can see it. After 7.5, my output is constant. Okay, and negative half cycle, same as input. V output is same as input. So this green line is the transfer characteristic. So I need to see this, those two values. Okay, I'll stop this video here. In the next video, I'm going to continue with another example. Thank you.